In today's session, we will continue with the solutions of homogeneous differential equation. Hi, I am Syed. Welcome to my channel Educate with Syed. Let's get started. The question is, show that the differential equation, this given differential equation is homogeneous, and we need to solve this homogeneous differential equation. In our previous videos, we have shown that whenever we want to solve a differential equation, then we substitute the value of y to be equals to v times of x, so that the value of v from here will become what? Cross multiply this x on the other side, it becomes y by x, right? And then we will try to differentiate this y with respect to x and get the differential equation in the form of dy by dx. So when you have the expression in the form of y by x, then you can differentiate this y with respect to x and get dy by dx. But here the expression that you are having is not y by x, but rather we are having x by y. So in that case, the substitution will not be y is equals to vx, rather it will be in this form: x is equals to v times of y, so that the value of v will be over here. Cross multiply that x on the other side becomes x by y. So can you see that we are having the expression in the form of x by y? So in this case, we will try to differentiate this x with respect to y. So hence we have to get it in the form of dx by dy. So let us try to simplify this one in such a way that we get dx by dy. So 1 plus e power of x by y as it is times of dx. So send this positive value on the other side becomes negative, minus e power of x by y times of 1 minus x by y into dy. So retaining this dx as it is, cross multiply the dy, it becomes divided by dy is equals to minus e power of x by y times of 1 minus x by y will be as it is. Cross multiply this value on the other side, it becomes whole divided by 1 plus e power of x by y. So if I express the differential equation in this form, dx by dy is equals to f of x comma y, then this particular expression on the right hand side will be nothing but the function f of x comma y. So here f of x comma y is nothing but minus e power of x by y times of 1 minus x by y, it is whole divided by 1 plus e power of x by y. We need to show that this given function is a homogeneous function, so that if this function is a homogeneous function, the given differential equation will become a homogeneous differential equation. Now how to show that this function is a homogeneous function? For that, we have to replace the value of this x by lambda of x, replace this value of y by lambda of y, so that we get lambda power of 0 into f of x comma y. Then we can say that the function f of x comma y is a homogeneous function of degree 0, because lambda power you have 0. If this function f of x comma y is a homogeneous function, we can conclude that the given differential equation is a homogeneous differential equation. Now let us put the value of x to be equals to lambda of x and y to be equals to lambda of y. So we get f of lambda x comma lambda y is equals to, so you have minus e power of x will be lambda of x by y will be lambda of y times of 1 minus x will be lambda of x, y will be lambda of y, whole divided by, it is 1 plus e power of x will be lambda of x and y will be lambda of y. We observe this lambdas will cancel out, this lambda will cancel out, this lambda will cancel out. We are left out with minus e power of x by y times of 1 minus x by y. It is whole divided by 1 plus e power of x by y. Now is this expression nothing but f of x comma y, right? So we have got back f of x comma y, but can write this as lambda power of 0 into f of x comma y. Lambda power of 0 will be 1 itself, so it is 1 times of the function will be the function itself. So we have got f of lambda x comma lambda y is equals to lambda power of 0 into f of x comma y. So when you get the function in this form, then we can say the given function f of x comma y is a homogeneous function. So therefore f of x comma y is a homogeneous function, is a homogeneous function of degree 0. If the given function f of x comma y is a homogeneous function, we can conclude that the given differential equation, hence differential equation is a homogeneous differential equation. Homogeneous differential equation. So what is the differential equation? We have dx by dy is equals to minus e power of x by y times of 1 minus x by y whole divided by 1 plus e power of x by y. Now we need to solve this homogeneous differential equation. For that we will try to substitute the value of x to be equals to v times of y. As I told you over here, if x is equals to vy, then the given differential equation will be in the form of dx by dy. Now since the given differential equation is in the form of dx by dy, where x is the dependent variable, therefore we are taking the dependent variable x is equals to v times of the independent variable. Therefore we have to put x is equals to vy. Let us try to differentiate this one with respect to y. So we get derivative of x with respect to y will be dx by dy is equals to vy is a product, therefore we will try to use the product rule over here. V as it is, differentiation of y with respect to y will be 1 plus y as it is, differentiation of v with respect to y will be dv by dy, or you can rewrite this as v plus y into dv by dy. Now we can substitute this value of x as well as dx by dy back in this given differential equation. Let me take this differential equation as equation number 1. So equation number 1 implies, now dx by dy is what? V plus y into dv by dy is equals to, it is minus of e power of x value is vy, so vy by y times of 1 minus x value is vy by y. It is whole divided by 1 plus e power of x value is vy by y. We see that y will cancel out here, y will cancel out over here, and y will cancel out over here. This will be further written as minus e power of v into 1 minus of v whole divided by, it is 1 plus e power of v. You can even send this plus v on the other side, it becomes minus of v, and here we are left out with y dv by dy. Let us try to take the LCM over here and simplify. The LCM over here is 1 plus e power of v. So let us multiply this one inside. Minus e power of v into 1 will be minus e power of v, minus of minus will be plus v into e power of v minus v times of, let us cross multiply this one, we have 1 plus e power of v. Further let us try to open the bracket and multiply. We have minus e power of v plus v e power of v minus v times of 1 is v, minus of plus will be minus v into e power of v. It is whole divided by 1 plus e power of v. We see that this positive and negative value will cancel out. Now here in both the terms negative sign is common, so I will take negative common outside. We are left out with e power of v plus v it is whole divided by 1 plus e power of v. Now let us try to cross multiply and get all v's on one side. So we get 1 plus e power of v whole divided by, cross multiply this value, it is e power of v plus v, and I will try to retain the value of dv as it is. Cross multiply the dy and y, it becomes dy by y, and this negative sign will remain as it is. Now this is in the variable separable form over here, therefore we will try to integrate on both the sides. So integral of 1 plus e power of v divided by, so let me write down first v and then e power of v times of dv is equals to minus integral of dy by y. Since it is in the variable separable form, so let us try to use the substitution method over here to integrate this left hand side value. Let us put the value of v plus e power of v to be equals to some t. Now let us try to differentiate with respect to v. Differentiate with respect to v. So derivative of v with respect to v will be 1 plus derivative of e power of v will be e power of v is equals to derivative of t with respect to v will be dt by dv. Now cross multiply the dv, will be getting 1 plus e power of v times of dv is equals to dt. So this value which is there in the numerator can be replaced by what value? Dt. So we get integral of dt by t is equals to, it is minus integral of dy by y as it is. Now we can integrate on both sides, so we will be getting log of mod t is equals to minus log of mod y plus the constant of integration c. We can take this log of y on the other side, it becomes log of mod t plus log of mod y is equals to c. Now this is in the form of log m plus log n, which can be represented as log m into n. So log of mod ty is equals to c, or ty will be equals to, you can take log on the other side, it becomes e power of c. Now e power of c is again a constant, we can replace that by some other constant k. That is, we have replaced e power of c by what? E power of c by the constant k. But here what is the value of t that we have taken? So t is nothing but v plus e power of v. T is v plus e power of v. Let us plug in over here. T value is v plus e power of v times of y is equals to k. But again this v also is expressed in the form of x by y. Can you observe over here? If you want to find out the value of v, then just x will be retained as it is, cross multiply that y on the other side. So v value will be what? X by y. But v value is x by y. So if you substitute here, we get x by y plus e power of x by y times of y is equals to k. Or if I take the LCM over here, y is the LCM, we have x, cross multiply this y, we get y e power of x by y times of y is equals to k. We observe this y and y will cancel out, we are left out with x plus y e power of x by y is equals to k. So that's the required solution we have. So that's all I have for today. If you like my video, please subscribe to my channel. Thank you.